This crazy binomial expansion question was sent to me by one of the Lung gang. If you guys are interested in joining the Lung gang Reddit page, link is in the description. What does it say? It says the coefficients of x to the power of n, x to the power of n plus 1, and x to the power of n plus 2 in the expansion of 1 plus x to the power of 23 are in an arithmetic progression. Determine the possible values of n. Okay, let's breathe. This sounds a bit mad. An arithmetic progression for the coefficients of those terms. What is an arithmetic progression? Just like at GCSE, it means that the sequence is going up by a constant value. For example, 3, 5, 7, 9, etc. It's going up by 2 each time. So it's saying the coefficients of those three terms are going up by the same amount. Okay, I guess what we need to do then is just find out what those coefficients are. Now what's helpful is that it's 1 plus x, so in the expansion there's no crazy business with the x's. It's literally the n choose r. Okay, so let's remind ourselves of n choose r. So n choose r is n factorial over, yes, so it's the number of choices for n unique objects. We divide by r factorial, and then we do n minus r factorial. Now x to the power of n would be your r. Okay, so the different powers. So remember, if we're expanding, I don't know, 1 plus x to the power of 5, you do 5 choose 0, 5 choose 1, 5 choose 2. 5 is always the power, and this tells you the power of x. So this would be the x power of 0 term, this would be x power of 1 term, etc. So in our case, we are going to write down formulas for n, well, sorry, n is 23 in this case. So we're going to do 23 choose n, 23 choose n plus 1, and 23 choose n plus 2. All right. 23 choose n, 23 choose n, 23 factorial. In fact, all of them are going to have 23 factorial on the top. Okay, I'll write it a bit bigger over there. Just want to try and save some space out here. Then it's r factorial. These are always the same, so we'll have n factorial. Here we're going to have n plus 1 factorial. And here we're going to have n plus 2 factorial. Then over here you do this minus this. So 23 minus n factorial. Here you're doing 23 minus this. That'll be 23 minus n minus 1. 23 minus 1 is 22. Then we have minus n factorial. Then over here you're doing 23 minus this. 23 minus n, 23 minus 2 is 21. All right? These are my coefficients, okay? So if I was to I'm going to write it like this first, so you see what I'm trying to do here. So we have 23 choose n, 23 choose n plus 1, and 23 choose n plus 2. They're going up by the same amount, okay? We have to work out by how much are they going up by. Because it's arithmetic, these two need to be the same. Let's go back to the 3, 5, 7, 9, etc. You guys take this for granted because you immediately say 2. You're saying this plus 2 is this plus 2 is this. It's just obvious. But what you're actually doing is you're taking them away. You're saying the difference between these two is 2. So you're doing 5 minus 3. This you're doing 7 minus 5. And this you're doing 9 minus 7. They're all 2, isn't it? So you're actually doing a subtraction. So what you're adding to go from this to this is this take away this. So you're saying 23 choose n plus 1 minus 23 choose n. And for this one, you're doing 23 choose n plus 2 minus 23 choose n plus 1. Okay? And then you're saying they are equal to each other. Okay? So you are saying these two terms, these two terms are equal. And that's quite nice because I see some common terms. All right? If I bring this to this, it can join this to be 2 lots of 23 choose n plus 1 is equal to, do I want to move? I guess I might as well move this to this side just to keep things positive. 23 choose n plus 2 and 23 choose n. And then we can substitute things in. We can sub in all these things, right? I'm doing 2 lots of this one. If I multiply by 2, it's going to go to the numerator. Now, I'm not going to do anything with that 23 factorial. I'm literally going to say 2 lots of, 2 lots of 23, not 3. 2 lots of 23 factorial over n plus 1, 22 minus n factorial is equal to this bottom one, 23 over n plus 2 factorial, 21 minus n factorial, and the 23 choose n, which is the nice and simple 23 factorial over n factorial, 23 minus n factorial. And we need to solve all this. There's definitely something I can do very nicely. They all have 23 factorial in them. I can cancel them all out by dividing by 23 factorial everywhere. Cancel, cancel, cancel. So these are just going to have 1 on them. This is going to have 2. The other thing I want to do is essentially what we're doing to solve this is we need to get rid of all the factorials, right? I don't like these denominators. It's looking a bit crazy. Let's do it one at a time. I could rewrite this and this in terms of this. How? What is n plus 1 factorial? N plus 1 factorial is take n plus 1 and multiply it by the integers that precede it. What term comes before n plus 1? It's n. Then we'll have n minus 1. Yeah, we keep subtracting 1. N minus 2, all the way down to 2 and 1. But this is just n factorial. So n plus 1 is equal to n plus 1 times n factorial. How about n plus 2? That's n plus 2 multiplied by the term before it, which is n plus 1, times n minus 1, etc., n factorial. Sweet. So that means I can rewrite all of these and I can cancel out the n factorial. So I'm going to have 2 over n plus 1, which is n plus 1. N plus 1. N plus 1 times n factorial times the 22 minus n factorial, which I'll deal with later, is equal to 1 over n plus 2, which I said is n plus 2, n plus 1, n factorial, times the 21 minus n factorial, plus 1 over n factorial, 23 minus n factorial. Now, multiplying through by n factorial, these are all just going to cancel. And now we need to figure out this business here. Now remember we cancelled out n factorial, we cancelled out the smallest one. So we need to rewrite the larger ones in terms of the smaller ones. So over here, you need to decide which one's the biggest. Well, the biggest is this, because there's the bigger number in front. Okay, we're going to rewrite all of them in terms of the 21 minus n. Okay, now 23 minus n factorial is going to be 23 minus n. Multiplied by the term before it, you're going to subtract 1. That minus 1 is 22 minus n. Then you're going to multiply by the term before that, which is 21 minus n. But then remember, you're going to keep going down, 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 all the way down to 1, so you get that factorial. With the 22 minus n factorial, that's going to be 22 minus n times the term before it, which is 21 minus n. Then you have factorial. Nice. So, let's rewrite 2 over n plus 1 22 minus n factorial, which was 22 minus n times 21 minus n factorial, is equal to this, which doesn't change because that one is the smaller one, m plus 2, n plus 1, 21 minus n factorial, plus 1 over 23 minus n factorial, which is all this, so we get 23 minus n, 22 minus n, 21 minus n factorial. Now, we can simply just cancel out the 21 minus n factorial. And then we are left with an algebraic fraction, which even my GCSE students can solve. Okay? My GCSE kids, if you're watching right now, let's see if you can solve this. So we're going to times through by 21 minus n factorial. And we have 2 over n plus 1, 22 minus n, equals 1 over n plus 2, n plus 1, plus 1 over 23 minus n, 22 minus n. I mean, I can't lie, this is a bit mad. So, what we need to do is we need to get rid of all the denominators, right? And we can do that by basically just multiplying through by every unique denominator. Okay? Now, what is that going to look like? Instead of me writing it on every single term, I'm going to write down what the common fraction would be and we'll just compare it, right? So we're going to multiply everything by n plus 1. We're going to multiply by 22 minus n. We're going to multiply by n plus 2. We've done n plus 1 already. And 23 minus n, because the 22 minus n is done. So here, this fraction, when we times it by this, the n plus 1's going to go, and the 22 minus n's going to go. So we're going to get 2 lots of all of this. So we get 2 lots of, should we just start expanding it now? Nah. n plus 2, 23 minus n equals n plus 2, that's there, and the n plus 1 would cancel, and we're left with this times this. So we get 22 minus n, 23 minus n. Then finally, the 23 minus n and the 22 minus n will go. We'll get n plus 1, n plus 1, 23 minus n, and n plus 2. Oh God. Let's, this is a bit crazy, I can't lie. I've got my calculator in hand. So, I have 23n. I have minus n squared. So that times that gives me minus n squared. Times by 2. Minus 2n squared. This is giving me, 2 times 23 is 46. But then when I double it, is 92. And this is giving me minus 2n. 23 minus 2 is 21 times by 2, 42n equals. Now for these ones, I'm going to write them here and underneath because then I'm going to add them together. So 22 times 23 is 506. Here I get minus 22n. Here I get minus 23n. Minus 22 minus 23 is minus 45. N, I get plus n squared. This one's easy. We're going to get n squared. 2n plus n is 3n. Plus 2. So we're left with minus 2n squared plus 42n plus 92 is 2n squared minus 45 plus 3 is minus 42. And then 506 plus 2 is 508. Bring the smaller one to the larger one. We're going to get 0 is, add that over, 4n squared. Minus 42 minus 42. Minus 42 minus 42 is minus 84. N. Then 508 minus 92 is 416. Which all of these are divisible by 4. Do I know 1? Ayo, this has appeared a lot, man. Then we have 416 divided by 4 is 104. My gut feeling is that does factorize. I mean, I'm praying it does, otherwise it's not looking good, mate. 1 minus, do I know 1? 104. Yeah, buddy. 8 and 13. Yo. But obviously you have to pretend like you did factorize. What an absolute beauty. Wait, did I do that? 13 and 8. Yeah. Yo. What a question. I'm hoping you learned a bit there. I definitely had fun finishing that question off. But guys, if you enjoyed today's video, if you learned something, hit the like button. It extends the reach to help all those other students who may not be seeing these videos. Subscribe for more maths content, and if you're interested in my A-level courses, links in the description. And if you want to submit your own questions and join the community, join the Lung Gang Reddit link. Battery died, obviously. I think I was saying join the Lung Gang, whatever. Like, subscribe, comment, all the good stuff. I'll see you guys in the next video. Nice.